Software engineering is a very interesting field of engineering. We differ from other branches of engineering in the simple fact that we use computers, which are a relatively new concept that I think we are all using currently to watch this video. All right, so let's first talk about the first aspect. What makes us different between the other branches of computer-based engineering? There's three branches specifically. There's software engineering, and computer scientists. Software engineering specifically deals with code. We're the one that opens up the IDE editor, types in the codes, hits it run, lets it compile, watches it crash 5 times, cry and scream, and then we have working code. Computer engineers, on the other hand, are the people that are actually working on designing the computer itself. Think electrical engineer, but specifically designed for computers, all right? A computer scientist is just a math major that wanted to do something with computers. All right, we don't worry about them, although they are very important in how we design algorithms and a bunch of other stuff. All right, so we don't worry about them. What's the average day of a software engineer? First of all, a average day will involve meetings and talking to people to figure out what to code. Once you have some code, you're then going to send those to people who her job is to test the code, which ironically are called testers. Those testers will then test your code in every which way to make sure it doesn't do anything it's not supposed to, give it back to you saying everything is wrong so you can recode it again, and the eternal cycle of coding, in that we always need to find the next bug to squish. All jokes aside, testing is a very crucial part of making sure our code works, especially if you want to deal with anything that deals with security, because if you have a security flaw, which we have seen in the past, bad things happen. Equifax is a good example of a recent analogy, but just go down the list of credit card, social security numbers, a list of things can go wrong. All right, how do we deal with statistics in our little grand bubble of engineering? Well, there are two major examples of where statistics are very useful in our branch of engineering. The first branch is actually Big O notation. Now, not to make this too complicated, think of Big O notation as efficiency of code. Big O notation very much revolves around statistics in that we will have maybe several different algorithms that deal with several different concepts that do with several different versions of Big O notation. So we might have a Big O notation of some random value, and we'll have another one that's some random value. We need to actually figure out where is it the most efficient in these stages. So we need to find edge points. We need to figure out what happens if I give it nothing, what happens if I give it too much, what happens if I give it the average case. All of this is data that we need to know to make our code work. Now, to get more complicated, the grand projects. We are in all of them. We need to be there to make sure that your simulation is working because we need to code the simulation. We need to be there because you are trying to figure out how this nitrogen cycle will work because you, again, need a computer. If you are doing anything in this day and age, you are going to need us because of computers. What do we specifically give to those grand challenges? What is our major contributor? And that is definitely in cybersecurity and advanced personalized learning. Cybersecurity is a little bit obvious. Our name is basically in it. We are software. We must secure our stuff. You need the Internet of Things. Data's everywhere. If you hear anything about information being leaked because of a code issue, there's a problem. It's complicated, and to discuss it in detail would require an hour-long video. So, second thing is the advanced personalized learning. And that is a little bit easier to do because we actually don't do that. Our goal is actually to give people the tools to do this. And this is where you can actually see this a lot online with videos such as YouTube and Khan Academy being able to produce a lot of information that you can use. We give you the resources to make that personalized learning happen. While we are useful in that step, we aren't a core process, but we are arguably one of the most important ones.